Substitute a value. When we replace the variable in the formula with the number, it is called substituting a value. When substituting, you must place the numbers in parentheses so that there's no confusion in the future. So let's go to our first example. Example 1. The ignition circuit is 3.3 ohms of total resistance and has a voltage of 13.2 volts from the battery currently. Find the current. So for this, you'll see this very common equation. So this helps us calculate either voltage, current, or resistance. So in this problem, we have total resistance and we have voltage. So this V is for voltage, I is for current, and the R is for resistance. Now, when we are substituting in values, let's go ahead and start doing that. So we have voltage of 13.2, and we have this fraction bar, and then we don't actually have current, which is what we're trying to solve, times resistance, which is 3.3 ohms. We're going to place these in brackets or parentheses. And then the next step is we can see that this 13.2 divided by 3.3 is our problem. And that will get us to how we find our current. So our problem is 13.2 divided by 3.3. Now, we could do multiplication in order to see how many times it probably goes into it, rather than going through the division steps. So we have 3.3. Let's go ahead and multiply it by 4, because 3 times 4 is around 12, so let's see if this works. So here we have this 3 times 4, which is 12. Carry the 1. 3 times 4 is 12, plus the 1 is 13. Then we need to deal with this decimal of just one value. So we just move it over 1, and we have 13.2. So 13.2 divided by 3.3 is equal to 4. And then the current is measured in amps. So we'll say 4 amps. And that would be our solution to this problem. Now let's go ahead and do another problem. Example 2. Evaluate the following expression, which is shown right here, with x equals -2. So essentially every time we see an x, we're going to put in instead now -2. So let's go ahead and do that. So this then becomes, we have a negative out here. Then we're going to place our parentheses here, because remember that we're always going to put the parentheses when we substitute in our value. So now we have this -2 raised to the second power minus 2, and then we have -2 minus 6. So let's go ahead and first deal with this as it's an exponent. So we have this negative sign out here, and then we have -2 times -2, and then we're just going to leave this like this for the rest, so we just don't forget to do that part. So now we have -2 times -2. And when we multiply two negative signs together, it's positive. But that negative sign out in the front makes the whole thing negative. So we're actually going to get -4 here. Then we have this next. As we dealt with parentheses, we've dealt with any exponents, and then we have multiply, divide, and then add and subtract. So this is the next one, as it's a multiplication. So once again, we have two negative 2's being multiplied. So that equals positive 4. And then we have minus 6. So for this problem, we have negative 4 plus 4, so that equals 0. And then we just are left with our negative 6. And that would be our solution to this problem. So let's go ahead and look at another example. Here we have the lighting system in a car. When not running, will draw 5.5 amps of current when the voltage is 11 volts. What is the resistance of wires and bulbs in the lighting system? So once again, we're going to substitute in these numbers into this equation here. So here we have current, and then we have the voltage. So let's go ahead and write 11 on the top, as that's for our V. Then we have 5.5. So that's our current, which is the I, times R. Kind of cover up the R and then just deal with this division sign, which is 11 divided by 5.5. And this will get us to resistance. So let's just do 5.5 times 2 and see where that ends up. So 5 times 2 is 10, carry the 1. 2 times 5 is 10, plus 1 is 11. We deal with our 1 decimal here, so we're going to place it right here. And that equals 11. So therefore, 11 divided by 5.5 is equal to 2. And this is measured in ohms as its resistance. And that would be our solution to this problem.